everyone. Many of you have seen the unusual patterns of my upload date. You might be knowing that I have done a secret project, and yes, I am making a thing. That project's name is Operation YouTube Protocol. That's a pretty long name. So I decided to make different types of videos to make such videos. Again, another update. So this is my reaction. So it's basically just a reaction, but also it includes these type of charts or these types of figures to be made so that I can actually use them more. So I might be not able to tell you all of these things, but it's just a human body thing. So I am trying to make another video or other videos. I can't say it more about now, but later I will say. So if you want to support us for that protocol, don't forget to like, share and subscribe. It helps our channel a lot. So we can see what our chart looks like. Remember, this is not from an outside source. This is made 100% by me, except for the physics of the impossible. That's from a famous scientist book. You must type the chart, otherwise you'll go to all sorts of booky stuff. So today is a really special day because today this is 3 years special, because this is the September 1st where my first video came at 2017. So today is actually 3 years special. Okay, so that's we covered all of that channel stuff. Now let's go back to our chart. So this is made 100% by me. You can see this is actually doing. This was actually from a channel named Useful Charts, and I have actually bought a couple of printouts of that. So I actually make the charts idea got from that channel. So make sure to check it out sometime after this video. Okay, so you can see this Genesis is from you can see it's kind of like a life thing. I made just in this life classification thing. Genesis is the beginning of time, meaning after the Big Bang, beginning of time has started. It was called Genesis. It will be really hard to understand the beginning, but at the end we will be getting like that. So you can see these are like the Eureka domain, bacteria domain and archaea domain. Substance, forces and energy are the thing. Since we are going to be knowing most of the substance, let's look a quick look at the forces area. So there are four forces. These are gravity, electromagnetic and weak and strong nuclear forces. But I count them as only 3 forces because, well, that's not a big thing. But also the atomic bomb came in at that time. Forces surely blew along with the Genesis. I will explain the atomic bomb later though. So since we have taken a quick look at the forces, now let's look at the quick look at energy. Well, energy is nothing more than a lot faster matter which bombard with each other to create some sort of energy or some sort of thing like that, compounds, etc., to create energy, different types of energy. It occurred during the Big Bang when things were floating around everywhere and crashing together because they have been packed together on a really dense space, and then imagine it exploding. Then they will go out anywhere. Like an inflating balloon with trillions of sand, you can inflate it like this, and it will the sand will start to move everywhere because, well, they have more space. So why not? I don't know what is the reason, but that's because of Einstein's 3 theories. Remember. No, Einstein's, not Einstein's, that's Newton's. These are so much funny. Okay, let's see. So what is related to gravity? Of course, that's Isaac Newton, because, well, that's it. So actually, the three laws of of gravity are, well, the first law states that when an object moves like this, nothing can stop it until it form any outside force. Like when you give a bowling ball on a long field, that just slows down, not because of Aristotle's word which state objects actually go tired, that's why they fall. That's nonsense to today's physics. But back then, this was the only explanation to that. I understand the thing which people were surrounding before Isaac Newton. So when I hit this chair, for example, I'm a bowling ball, a giant bowling ball, like an egg, it hits that, but doesn't, unless it breaks, it will just stop, because it's from an outside force that it's doing it. Similarly, when I take this and push it like there, it is actually pushed by something. Otherwise, it would be in the same thing. You might be wondering, why is this moving a lot slowly? Still, it's moving without any outside force. Well, that's because there's air all around us. We don't notice it, but when you go through a long runway like this, or do like something like this, you can feel the air going from one area to another. When I can do this, I also feel that the air is going there. Air is matter and will be matter. So let's now see what are the energies after all that physical thing. Well, firstly we're gonna know the two main things which occurred: kinetic or kinetic if you are more English speaker, but I'll say kinetic anyways, and heat, which is the thing. So why heat came? It was even before the Big Bang, since they were really hot particles on a densely area. Kinetic energy occurred when the objects blast away on a long space, and hence kinetic energy was formed. So what are energy? Well, energy is a subdivision just like a substance. It just swaps into another form. It can be destroyed or be created. For example, when I'm doing this, something like this, I'm wasting energy, but not actually I'm wasting energy. I'm just transforming it into another form. This is chemical energy, which I turn into mechanical / kinetic energy. Oh, speaking of mechanical energy, let's just go to that. What is mechanical energy? Well, that's just kinetic energy, but more used in industrial things. So that's the same thing. Static energy, though, is something like this. You take a brick and put it over the stairs, and it slowly goes down. You are swapping it into another form. That's what energy is. But there is the kind of energy which, when you swap it in another form, that is another energy. So let's just think. So there are two kinds of energy, which are the main one that you need to learn on school. Not much of these. I am going to say that later. You are going to just know two of these mostly. Kinetic energy / kinetic, which was created by friction on the early stages. No matter for that. So kinetic energy, and there are potential energy. That means you are standing like this here, but you can do something. For example, if I go here, when right in the moment when I was there, I had potential energy, so that I can do something, go down and pull into the ground. That's what occurs. Now let's go to the other forms of energy. You might not need it. Air and wind are the same thing, but they are just doing. So their air is kind of energy, but it's kind of a substance, so it's not counted as energy. But wind energy is a thing. When you move air, that forms wind, but that's energy, kind of energy. So that counts as energy in this. It also forms breeze and storm, which are kind of that, but I won't include it. From heat we get electricity. When it gets extremely warm, over these light bulbs above me you cannot see, these are produce light. That's why they are called resistors, because they kind of use static electric energy so that they can swap it into another form, kind of like resistors. They are actually a resistor but are useful for our daily lives. So we learn all of these. Electricity forms light bulbs. See this little picture here. I also took this idea from the useful charts. Remembered about that. Static electricity and current electricity are two types of things. Static electricity is kind of a different thing. So, for example, when you have a famous experiment where you actually run something along here which is not a conductor. Conductors mean they can conduct electricity and go pass it into another form, and insulators cannot conduct it at all, and resistors block energy from going anywhere, electricity from going anywhere. Current electricity is what conductors conduct and makes them current electricity, and static electricity is when charges built up at somewhere. And clouds, so you can see that when lightning occurs, ice and air rubs together to form friction. This causes extreme electrical charges to build up in that, causing static electricity until it transforms into a current electricity by lightning. So these are the things which I said about these. Oh, back to the atomic bomb. I forgot to tell you that atomic bomb is actually an energy source, because that actually when attacks, actually explodes, so that creates energy, and that's energy kind of. So let's just go out. So we go to all these areas and go to the substance area. This is what we are going to focus on, because you and me are made of this matter. We don't care about energy, although that's really important, but we are going to be looking at this. That's why I've given more of these in this area, because you'll want to know more about this. Okay, before you get, I have a warning for you. I have only given a black hole for a little information in here, so just for that. Substance has there were subatomic particles. I mean, when you might know that electrons and protons and neutrons are inside an atom, but they actually, when you smash them, you get more particles, and when you smash even them, you get more particles, and so on. In the Large Hadron Collider, they are trying to make an experimented effectal and thing called Higgs boson, something like that. So that they are trying to find out if that's actually real or something like a scientific legend that's not impossible compared to the future. So proton, neutron and electron. If you are seeing this at 2100, you are no, you are not. I am knowing, because this video YouTube might not survive back then. So actually you might think some of these laws are funny because these are so small compared to you. You are probably not watching from 2100, aren't you? So electron, neutron, proton. Proton consists positive and neutron consists no charge, and electron consists negative charge. Until we go to matter. Actually, if we go 1 generation, we create atom. 1 generation means actually one thing passing. The matter is not pretty important to discuss. The sources of matter are important to discuss. Atom, here's a simple thing of an hydrogen atom. So this is simply an hydrogen atom, where I have given a little yellow you might not be able to see, and blue which are proton and neutron, and here's a little electron. which is circling around it. This is a hydrogen model. That's the first thing and the easiest. Hydrogen is formed here until we go to the periodic table. Okay, there are also planets created by matter, more on that later. And let's just go to the 3 states of matter. That's solid, liquid and gas. Also there's plasma, which is a something, and other matter things you might find on the internet, but they are officially not counted as matter, but still there are actually 5 states of matter. But let's just see. So water plus gas equals steam or water vapor. Water plus solid equals ice. So it just freezes or melts or condensates and go from one form to another form to another. So we have covered this area, but also plasma is an cosmic source. That's because it's from stars, so that's it. Gas also forms stars, which later collapse into black holes by supernova, or if the star is really young, or no, actually really large and has a lot of mass, it will collapse into a neutron stars, which actually end by types of Hawking radiation, the same thing that evaporates black holes over time. So let's see, the periodic table, as we are at, also created life by new things. But you might have noticed one thing I'm not gonna explain. There's chemical energy also from that, and hydrogen bomb, which is a source of energy. Let's just go out of all that. What is technology though is a big important in the scale of physics. Let's see how small is technology compared to that. So mechanical energy plus chemical energy, and which will turn into electricity, plus metals and a few shapers by metals and etc. until a complex device is created. That's how it's evolved into a scale of technology. I'm not saying all of you who are studying technology from that plane. In fact, I study technology. I'm just saying how small it is in the scale of the physics. How small in this physics chart is it. I didn't discuss all the subatomic particles because, well, there are a lot of them. There are leptons, etc. Let's just go on to the next. Now I'm going to state what is astrophysics and quantum mechanics. Okay, quantum mechanics is kind of like a puzzle waiting to be solved. How to do this? By the way, I can actually do this at 15 minutes, but on real life, think of the world trying to help humanity and solve this puzzle. Think of the world solving this puzzle like this. Humanity doing this thing. It's a big thing, but it's actually not really easy. As you might think, this chart is really small on this chart paper. But I have mentioned nothing about the subatomic particles. There are thousands of that. And how to make chemical energy to oil. How does all these things form? Big Bang theory is enough, but that's not enough to piece together as the entire story. In fact, it takes us weeks, days, even years to finish one thing. Imagine you solving this puzzle for 2 years. What did it feel like? That's a big thing, and that's something about that. So it's like something like a puzzle piecing together, but in fact it's a large puzzle. It's kind of like over the expanses of space. We are trying to solve and take the entire story, but so far humanity has taken no information, and we only know 5% of the ocean, And that, if that doesn't surprise you, because we have only explored 5% of the ocean, that means we have not explored the rest of the 95% is a mystery to us. But only 3 people have landed to the Mariana Trench. Many people have gotten into the top of Mount Everest, but only so far around 29 people, 12 people have walked the moon. No people have gotten into Mars. No people have gotten into Mercury. No people have gotten into Venus. So no, not about that. Venus is a lot of pressure. But still, why haven't we pieced together the entire story? Think of this. How will it benefit us? This is one of the most asked questions, so I'm answering this. How will it benefit humanity? Check out Michio Kaku's briefing so that you can actually understand that. Okay, back to the story. I mean, how? How will it help humanity? Well, to piece together the entire story, it helps humanity to understand how it will benefit them. Oh, think of something like this. And people say you that if you give me 200 pounds of chocolate, but over the special edition, I'll give you an iPad. This is kind of an example of how is that. So you decide to piece together why it occurred. Why he is giving an iPad in exchange for the special edition chocolate. It is so cheap. Maybe because it's not better quality. Maybe because nothing. That's why people tend to piece together this thing. Through that, we can understand how physics, the full story of physics, how it actually occurred. Although physics was discovered at only 1600s around Isaac Newton. But it is a real weird thing. It will actually help us to teleport. Imagine you just got into a time capsule and got into that area and go to your office time capsule. This could be the future. In fact, entanglement has already done small particles to go to an area which have gotten back to that area. That's teleportation. But yet, we only transfer the data of that thing. Data for our cells is what matters, not our cells themselves. So if imagine this area is that time machine which will give you back, or no, actually teleportation capsule, and this area is another area. You can actually go to lunch from Paris to New York by actually going into that capsule. Your cells are dead on the first station, but at the second station, similar particles form a similar you. It matters the data of your cells, not the cells themselves. Although that might seem like a torture, check out CTP Gray. He says that it's a dead thing. That's a big mistake to point out. It's like torturing people. That's a big mistake because he doesn't believe in quantum mechanics. So far I have covered a lot of things. Let's go back to the thing. So I was around the periodic table, but I didn't explain what are there. They have reactive metals, basic metals, etc. You might find anything or nothing sort of thing, but also we need to explain what is antimatter. I had so far made one video about that of antimatter in YouTube. Antimatter and anti-atom are the same thing, except that their antimatter, which is also anti-liquid, etc. Has everything borrowed of the matter. I won't give it. And anti-atom means all the rest of atoms, the anti-periodic table. This is a map of anti-hydrogen. The same thing, I know it's the same thing of hydrogen, but actually these are these are actually electron and these are actually neutron. So it's kind of like an inverted atom. By the way, when you collide these two things, it forms the greatest explosion by E equals mc square. Means that mass and the speed the particles go upwards causes it to become mc square. That means double the square the thing of the square the actually the speed of light, and this causes a lot of energy. The biggest atomic bomb could be made like that. This is the strong nuclear force. Let's now go to the periodic table to see some amazing things. So we learned that these actually got to gas, star and black hole. We have explained that so far. Let's now see these things. So we go from Big Bang to one thing known as vacuum. It never existed during the early forms because it was so dense. Again, it was so dense that it had no space except for particles. Until there were plenty of spaces. The original particles which have been a lot densely packed, which is now on my skin. You can see on your skin anything. In fact, the camera we are taking from, anything that is matter except for energy, light, etc. Anything, this board, anything could be actually made of that particle. So that vacuum has two types of things we care about. That's, wait, I can't read that. Wait, what was that written on? Oh, it's just dark matter, just dark matter. This carries 65% of the unraveled universe, yet still this is not discovered yet. Dark energy is another thing. It contains around 14 plus 20 equals 34 and 34% of the universe. That's the thing. So that means 99% of the universe is unraveled, and only 1% is matter that we know. My hand, everybody, my 65 subscribers, my cameraman / producer. Let's just go out. So vacuum, there are two types of things which are created by vacuum. Space-time was actually Einstein thought it as a fabric, kind of like this. If I kept it like this and put a barbell on it, it will create some gravity that I am thinking, and that will roll around that. That's simple. And exotic matter, which is negative matter, meaning if I come close to another object, I will just be thrown away like this, unlike positively charged matter that tends to come together. This could be the possible thing for space-time, remember. So this is quantum mechanics. This is things, and don't forget to check out the channels I said, and don't forget to wait until stay tuned for my other videos of Operation YouTube Protocol. And so bye guys, see you next time.